I would like to add that I'm a proud CEO of Bright2. I'm happy to contribute to the transition that the industry is going through, and would like to explain a bit about how we are trying to do that in implementing some of the technologies and the ideas we have, rather than only talk about it. First of all, I would like to set the scene of my initiative. Basically, it is to provide green hydrogen to the chemical industry. There's a lot of discussions about green hydrogen for energy, for other purposes, but I'm focusing on green hydrogen for the industry. And as you all know, this is not to educate you, but to just put the scope together. Hydrogen can be made through electrification, from biomasses, from natural gas and coal. And basically there are all kinds of chemical processes and industries linked to that. And that's what we're trying to link into. So the challenge that we see is basically already mentioned a couple of times today, is that the consumers and the government want to get rid of fossil fuels, carbon footprint reducing, want to reduce the carbon footprint, and to increase the circular economies. And how to do that is one of the things that a lot of energy and thinking power is put into. So if we look at the green energy and the green chemical industry, at this moment there are no or limited proven technologies and solutions which are scalable and cost competitive to solve this issue, or at least to link into that challenge and make it happen. What we're doing at Bright2 is that we're working on one of those solutions. The solutions we're thinking of is that we are going to take bio raw materials, so biomass, woody raw materials, and convert them into renewable hydrogen, which is basically, if you calculate it all the way through, carbon negative. On the side, we're producing bio carbon dioxide, producing char, so carbon, and we're producing biosteam, which we will probably supply back to USG in the nice pictures that Ronnie showed us. Now, most of you will say that's a good idea, and the industry will say that's a good idea. But how do you implement good ideas? That's what it's all about. There's many good ideas that stay an idea, and they go into either a development innovation funnel, optimization funnel, financing funnel. So there's lots of challenges how to get your idea really implemented. So you can approach this solution in two ways. You can look at the raw material side and try to find a strategic link into the raw material that you're trying to use and to focus your project on that. For us, that would mean woody materials, Finland, Sweden, Norway, Switzerland. I don't know where all the forests are, or at least where the wood processing industry is. The other way to look at it is to find a strategic fit with the products that you are actually, or with the consumers of the products that you're actually producing. So we decided to go for the second, to look for a strategic fit of the solution with customers in mind. So not to develop a technology, but to develop a business. And for that, we looked at the Chemelot Industrial Park, which was also explained to you. And we looked at the case study 2020 that Chemelot has put in place and is putting a plan in place, but also an implementation plan for that. If you look at the situation at Chemelot on a very high level, what you see is that the situation a couple of years ago was that Chemelot was based on raw materials like electricity, natural gas, and naphtha oil, like was explained already before as well. And from that, there are products produced, fertilizers, nitrogen products, and plastics. That will not disappear. There will be products produced, and if you look at polypropylene, polyethylene, that will stay. That is not going to go away. People are trying to find other ways of producing these products in a sustainable way, rather than inventing new plastics, which is also happening. But basically at the big industries, you want to fit into their existing kind of product portfolio and technologies. Then you see there is some mechanical recycling going on, where the plastic waste streams that are generated are put back into the system to generate recycled plastics or to be combined with new plastics. The vision that Chemelot as a community has for 2015, which was published and discussed a lot, is that in 2050 the site will depend on green electricity. That was explained today as well. It will be based on bio raw materials, whatever that may be, but it will be based on sustainable raw materials rather than the oil that they're using at the moment. Producing the same products or similar products as are done now. So not touching the base technologies, but really looking at how you can implement sustainability without jeopardizing the end products that you're producing, which are important for the world. I mean, we're producing products that have value. So you don't want to get rid of the products. You don't want to get rid of the production sites. You want to make them sustainable. Where electrification, as was explained before, is one of the ways forward to make that happen. If we look at all these raw materials, one of the raw materials that we could also supply is green hydrogen, and that's what we're focusing on. There's a high demand for hydrogen, as was also explained today at the industry, and we are going to provide a green variation that, but then in combination with carbon. A lot of the discussions around hydrogen are focused on electrification of water. You make hydrogen and oxygen. However, there's no carbon produced. The carbon you have to still source somewhere else. With our view that you make it from a woody and a biomass material, that includes carbon. So you're actually making syngas as a product that you then further upgrade for the, let me say, for the community that you're doing it for. So basically we see ourselves as a third or at least a side feed into the Chemelot site of the future, providing hydrogen and then also thinking about the carbon. The way we're doing it is that we're looking at technologies not as innovation, not as development, but implementation. So we have chosen 3 main technologies that are available in the market to certain TRL levels, so basically ranging from about 7 to 10, depending on how commercial you take it. And the way we're going forward is that we're using torrefied bio raw materials. I'll go into that in a minute, why we do that. That's a commercially available product, although the quantities and the capacity of the current industry is not yet up to par with the future of 2050. So also there, investment will need to be done. We're taking a gasification technology, which is under the later stages of development from Torgas, which is a partner in this project. They have produced a 1 megawatt operation in Groningen, and they're at this moment in, I think it's the EPC level of the 30 megawatt, also in Delfzijl in the north of the Netherlands. And then you produce syngas from this technology. The syngas, as such, is a basic ingredient as a raw material for the chemical industry. However, if we look at the site here, there is an immediate need for green hydrogen. So what we do, or we're going to do, is to shift the syngas into a more rich variation where the hydrogen comes out. So we're using a water shift technology which is going to be, or which is commercially available and can be implemented straight away. So basically we are focusing on making the hydrogen out of the syngas, whereas the syngas itself could be used for a lot of other purposes. Just a word about torrefied raw materials. I was talking about woody materials, so biomass or waste streams. Now wood consists of about 80% water. So if you want to ship that from one side to another, you're shipping water. That's not what you want to do. So basically a lot of technology development is done in woody areas or where the wood industry is. We're trying to decouple the raw material with the processes as much as possible. And for that we are intending to use what is called torrefied wood. So you basically make a kind of a charcoal out of wood, taking the water out and some of the other volatile components, which makes it processable, so it becomes a pellet which can be used in an industrial way. So on commodity level, you can put it in silos, you don't have any issues with branches of cut-off trees and stuff like that. It's a unified version of wood. By taking all the water out and charring it, actually you increase the energy density. So it starts to make sense to ship this from one country to another, or from a woody area to an industrial area. You can still stay local. I mean, I'm not saying you need to transport it, but basically it decouples a bit where the wood and the waste comes from where you want to produce your chemicals and where the chemicals are already being produced. Because you cannot just take Chemelot and put it in Finland, you have to do it the other way around. The other benefit of the torrefication process is that you make a uniform material out of it. One of the issues with taking biomasses is the diversity and the variation in composition and in what's in there. That can be reduced or made more homogeneous by torrefying it. The technology for the gasification, the first two lines are still on the torrefied biomass, but the gasification is basically a two-stage process. If you normally burn or gasify or use pyrolysis systems and you do it in one stage, there's a lot of issues with tars, other stuff coming out of the burned, or at least the charred biomass, that cause a lot of issues in the syngas production. What we have chosen is a technology that is actually first taking the ashes out of the pyrolysis gas. So first char the biomass to a gas that can then further be, let me say, gasified in the second stage at higher temperatures to crack it down to the syngas. But that gas stream is very clear, very clean. So basically you don't have a lot of issues downstream in the processes. And the benefit of doing the first pyrolysis is that you actually make a char, a biochar, so that's a carbon product that actually has a lot of value in the agriculture as a, let me say, a earth improvement or an improvement agent, or in the industry itself. So the byproduct carbon is already a main product for us in the future as well. So basically using everything that you put in into valuable products afterwards. So just to summarize the scope that we have, we want to put down a 50 megawatt facility. 50 megawatt means about 6 kilotons of hydrogen, about 100 kilotons of bio CO2, about 50 kilotons of char. So we call it a demonstration plant, but basically it is a kind of commercial, or at least a full-fledged facility. We do it on the gasification of torrefied bio raw materials, so like I said, woody materials. The carbon that we use are either in biogenic CO2, so basically it can be used and seen as green CO2, and the biochar, which has value as well, besides the hydrogen, obviously. The timing for the process is that we hope, if everything goes like it should go, and we all know that that never happens, so basically this is my current guesstimation, to have this operational in 2025. We do that together with Torgas and Brightlands. So basically Brightlands is one of the partners that is actually providing also a lot of insight on the plots that we can use here on site, and also giving us the backup in all kinds of arrangements. And it's supported by the LEOF Local Investment Agency and InvestNL. The challenges that we have, and those are very general, but could apply to anyone, and I just put them down also as a bit of a discussion paper. We need to survive the valley of death. We have to get money to keep going. So the main objective is always to find investors that believe in your vision, or in my vision in this case. We have to find a position next to the electrolysis positioning. There's a lot of attention into electrolysis, there's a lot of subsidies, there's a lot of push, there's a lot of effort in getting that further. And we need to find a position next to that, not instead of that, but next to that, and give it value so that also people are willing to invest in these kind of technologies. We have to create the hydrogen and the biochar at the high levels of specification and pureness for the application that we're targeting, which is a real great challenge. We have to also fight for subsidies for a chemical process. Chemistry and chemical processes are not always the most liked ways to go forward for subsidies. But that is something that we have to fight and also find. And then one of the other issues that we're facing is that some of the woody materials and biomasses are seen as waste. And waste is something you cannot transport over borders, or at least not easily. We have to find a way to end the end of waste status, because also our customers don't want to buy waste from us. So that's another challenge in where we stand and how we need to go forward. Final slide. Where do we see this going? Well, if we're successful in implementing this 50 megawatt, there is an opportunity, potential opportunity, to even increase the, let me say, the demand at Chemelot to 250 or 300 megawatt. This also means that you really become one of the major players here in the hydrogen supply, so that also means that you have to look at what other people are doing and how you would strategically fit into this. This is only an option. The same idea that we have could be implemented at other landlocked chemical sites. Something that could be multiplied as an idea, but also as an implementation on other chemical sites in Europe. And then basically the other, let me say, link to it is that torrefication will need to increase its capacity, but also give the opportunity to increase because of these processes. So you also stimulate another industry, which is a supplier industry to us, to do investment into new technologies and into using biomass, which is kind of always mentioned, but with a concrete implementation plan into the industry. That's what I prepared.